Okay, find the equivalent resistance between points A and B in figure below. Okay, so between point A and B is the main circuit. Yeah, what I can say is the main circuit, point A and B. So this is the main circuit. Yeah, the main circuit is here. Well, okay, actually this is not a complex circuit. Yeah, it looks simple to me. 7 ohm and 10 ohm should be parallel. Combine these two, then we have 3 resistors in series. Then we combine all of them in series, then we can get the total resistance, right? So let us straight away do it. Yeah, so always okay, start with question A. Okay, he asked us to find the equivalent resistance. Equivalent resistance, that means is the total resistance. Yeah, equivalent resistance means the total resistance or resistance between AB. Yeah, resistance between AB. So okay, so equivalent resistance. So we start off with you know, we always start with branch. Yeah, look at the branch, then only go to the main circuit. Okay, so our branch is the 7 ohm and 10 ohm. Yeah, we should solve this first before we can solve the main circuit. Understand? So 7 ohm, oh, where is 7 ohm and 10 ohm? Okay, this one should be in parallel. Why? Because there are 2 legs connection. You see that? Both of their legs connected together. Yeah, one leg of 7 ohm and another leg of 7 ohm also connect to the same resistor. So this is a 2-leg connection. This is a parallel combination. Okay, so okay, maybe I should label first. This one as R1, this one as R2, R3, R4. That way should be easier lah. Yeah. Okay, so R2 and R3 should combine first. Okay, R2 and R3, they are in parallel because they have 2 legs in connection. Yeah, R2 and R3 parallel. So how to total the resistance in parallel? Okay, we know that resistance in parallel become a smaller resistance. Yeah, become a smaller resistance. So it's 1 over R. So 1 over R. So 1 over R23 equal to 1 over R2 and then 1 over R3. Okay. So R2 is 7 ohm plus R3. R3 is 10 ohm. Alright. Okay, so total them. Okay. Now punch calculator and see. Let me calculate, yeah. 1 over 7 plus 1 over 10. I will get I get 17.70. Is this the R23? No, this is not R23 yet. This is just 1 over R23. So to get R23, don't forget the very important step here. You need to, you need to inverse. Many students forget to inverse. Many students forget this step. Invert this. Same like the capacitance last time. Many students forget to invert. Okay, so don't forget to invert. You will get 70 over 17, which is okay. Let me see the answer. It is 4.1176. 4.1176 ohm. Okay, that's R23. That's R23. Is that correct? Okay, you look at here. As I told you, resistor in parallel should become a smaller resistor. Yes, it's around 4 ohm. 4 ohm is definitely less than 7 ohm and 10 ohm. You see that? It's less than 7 ohm and 10 ohm. So parallel resistor really become a smaller resistor. Alright, so this answer is correct. Okay, next, after combine R2 and R3 combine become R23. So here we have R23 already. Okay, so now R1, R23 and R4, they are all in series. They are all in series because they all connect with one leg. One leg, isn't it? The one leg of R23 connect with 4 ohm, another leg connect with 9 ohm. So it's connect to different resistor. So all these are in series circuit. Okay, this is in series circuit. So combine these three. Okay, combine these three. Okay, we can say R1. Okay, hold on a second. R1 and R2, 3, and R4. They are all in series. They are all in series. So series. Okay, so series. So now okay, R total. So we can find R total is equal to R total is just series means the resistor becomes stronger. No, I mean resistor in series become a higher resistance, because it's plus plus plus. Yeah. Resistor in series, resistor become bigger, bigger resistance, so it's plus plus plus. So okay, it's R1 plus R2 3 plus R4. So R1 is 4 ohm, R2 3 is 4.1176, which I got just now, plus R4 is 9 ohm. Okay, 9 ohm. So total them up. So what do I get? Plus 4 plus 9. Okay, so I got 17.1176 ohm, which is okay. I round it up, so I got 17.12 ohm. Okay, that's the answer. Is it correct? Yes, it's correct. The equivalent resistance is 17.12 ohm. That's correct. 17.12 ohm. 17.12 ohm. That's correct. Okay, you see, resistor in series always become bigger. You see that 17 is bigger than 4, bigger than 4.11, bigger than 9. So it's always become bigger. Okay, resistor in series. Okay, so that's the total resistance. So now I want to find B. If the voltage potential difference of 34 volt is applied between A and B, calculate the current in each resistor. So now there is a voltage of battery of 34 volt. This should be the total voltage. This should be the total voltage. This this 34 volt should be the total voltage. Yeah, of okay, this one, the 34 volt should be the total voltage connecting A and B. Total voltage to the total resistance here. Now I want to find the current in each resistor. That means I need to find the I1, I2, I3, I4. I need to find the current through R1, current through R2, current through R3, current through R4. So as I told you before in example before, I told you the flow of work is always like this. You see that? It's the same as the capacitor before this also. Okay. That's the flow of work. We always, what do we do? This is the important thing. Let me highlight it. Yeah, let me highlight it. Yep. This is the one. Okay. So the step is always, you see the first part, he asks you to find the total resistance. That's the first part, total resistance. And then he surely asks you to find, you will need to find the current, total current. That's the next step for us in part B. We need to find the total current because he gives us a total voltage. And we need to find the total current. After we got the total current, then only we can find a voltage in each resistor and also current in each resistor. So right now we are in phase 2 already. Phase 1 already solved in part A. The total resistance, we already got this. Now we need to find total current before we can proceed to step 3. Understand? Because we got the total voltage. Now we need to find total current. Okay. So okay, now let's do it. Yeah, let's do it. So part, where should I write? I think I just write where should I do it? Yeah. So okay, wait. This one I just drag below here. I think it's better. Okay, that's for part A. Okay, I got the answer already over here. Okay, that's part, you know, just want to make my work more systematic. What is this? Come on. Okay, hold on a second. All right, that should be better. Yeah. I like systematic work. Okay, so now, okay, that's part A just now. Now let's start with part B. Yeah. Oh, what is this? Hold on a second. Hold on a second. Yeah. Okay, so now let's continue our class lesson. Okay, so okay, now I want to do part B. I want to do part B. Okay, so right now we are in the second phase. We need to find the total current already because we already got the total resistance and total voltage, right? Total voltage 34 volt. So we just use to find total current using V equal to IR. Okay, V equal to IR. So since all total voltage, total current, total resistance. So put in our total resistance here. Okay, and the total voltage, we can find the total current. So my total voltage is given is 34 volt applied across A and B, right? That's the total voltage. 34 volt, yeah, 34 volt. Put in 34 volt. 34 volt. The total current, total resistance is 17.12 ohm. Okay, so what's my total current? What's my total current? So 34 divided by 17.12. It's I got the total current as 1.98. Put more decimal place, yeah. 986 ampere. I put more decimal place, so more accurate. Okay, 1.986 6. That's correct. 1.986 ampere. Okay, so I got the total current. How will this help us? The total current. Yeah, remember this current will pass through. This is the total current. I can say, okay, look at this diagram. This is positive, this is negative. So the current coming, this is the total current coming, so this total current will pass through 4 ohm, yeah, pass through the R1, and also pass through R23, and also pass through R4. Okay, so this R1, R23, and R4, they are in series. As we learned before, for series resistor, the current is the same for all. I total equal to I1 equal to I2 equal to I3 is the same. The current is the same for all, isn't it? So we can apply this relationship here. Series. We start with series first. Okay, so we can say, all right, let's start our lesson. Yeah. How many times we need to start our lesson? Okay, so all right, so we can write like this. Yeah, we can write like this. R1 and R23. R23 is a combination between R2 and R3. Yeah, we combine become R23 because they are parallel. Yeah. Okay, and then R4. They are all in series. Write this relationship first. It will help you. Yeah. They are all in series. R1, R23, R4, they are in series. So series, that means they have the same current. Because only have one circuit. They only have one circuit. That means the current will pass through the same for all resistors. So the current is the same for all. I1 equal to I2 equal to I3 equal to I total. So I can write over here. The I total, which I got just now, I total, will be equal to the current passing through I1. Current passing through R1, which is I1, yeah? And also equal to the current passing through R23. Also equal to the current passing through R4. Current passing through R4, which is I4. All these are 1.986 ampere, same current because series. Okay, so I got already my answer. Current in each resistor. So I need to find current only, isn't it? I don't need to find voltage. I only need to find current. So current in each resistor, I have R1, R2, R3, R4. So I1, I2, I3, I4. So I already got I1. See that? I already got I1. The current passing through resistor 1 and current passing through resistor 4. So all of them, they are 1.986 ampere. Okay, I got the first answer already. Now I need to find the current I2 and I3. The current passing through resistor 2 and current passing through resistor 3. So I don't have that yet. So I will need this. I will need this I23. Okay. I will need this I23. Okay. So from here, just now I1, I4, I solved already. I already got the answer. Yeah. I23, I will need it to I23 is 1.986 also. I will need this to find I2 and I3. Because why? Why I use I23? Because it has the closest relationship with I2 and I3. Understand? Okay, so that's why I use I23. So I23 can help us to get what? What do you think? I23 can help us to get? I have resistor 23, isn't it? I have resistor 23, so I also have the current 23. I can find the voltage. Understand? I can find the voltage. So this one can help us to find the voltage. Voltage V equal to IR. So again, this one is all current 23, resistance 23. I already got resistance 23. So I can find the voltage 23. This voltage 23 will help us to find even more information we need. Yeah. So now let's substitute the current 23 over here. 1.986. 1.986 and then resistor is 23. Resistor 23 is 4.1176. Yeah, 4.1176. 4.1176. So okay, let's find the voltage. 1.986 multiply 4.1176. Okay, I got the voltage is 8.1776 volt. So I got the voltage 23. So voltage 23, do you think is helpful for us to find the current 2 and current 3? Right now I got the answer for I1 already. I1 just now is 1.986 ampere. I4 also I got already 1.986 ampere. I don't have I23 yet. I2 and I3. I don't have I2 and I3. So this voltage can help. Do you think can help us? This voltage 23 can help us to find I2 and I3? Definitely can, because it has some relationship. How to find the relationship? So use your head. Use to think a bit. Yeah. Voltage 23. You see, these two resistors is in parallel, isn't it? R2 and R3, they are in parallel. Parallel, that means they have the same voltage. Resistor in parallel means they have the same voltage. V1 equal to V2 equal to V3, same voltage. Use this relationship. Okay, use this relationship. So now we arrive to the next step is okay. So we can find. So now we can go to here. We can say what can we say? We can say this R2 and R3, they are parallel. R2 and R3 are parallel. Okay. So what does it mean for you? For this one, R2 and R3 parallel means they have the same voltage. Voltage 2 equal to voltage 3. Resistor in parallel have the same voltage. So I can say that the voltage 23 just now, the voltage 23 just now is the total voltage between resistor 2 and resistor 3, V23. So this total voltage will be equal. It will be equal to voltage 2 and equal to voltage 3 because they are parallel. That's how the voltage 23 will help us. V23 equal to V2 equal to V3 because they are parallel. Because they are parallel. Understand? And also equal to equal to 8.1776 volt. This is how it helps us. That's why I say use your brain. All right. So okay, so this V2 definitely can help us to find I2, isn't it? V3 can help us to find I3, isn't it? So how are we going to do it? V2 and V3. So let's do it. Okay. How are we going to do it? Use the formula V equal to IR. V equal to IR is so important. You see, we got V total, I total, R total. We also got V23, I23, R23. Now, right now we have what? We have V equal to IR. We have this one also V equal to IR. Right now we have what? We have V2, I2, R2. That's the I2 we need to find. And here is V3, I3, R3. That's the I3 we need to find. That's I say. V equal to IR, Ohm's law is so important. Just the same as capacitor last time, Q equal to CV. Q to CV. Last time also we use this one. We have Q total, C total, V total, and then we also have what? We also have Q, Q, and so on and so forth. You know what I'm saying, yeah? Yeah. We also Q23, the combination, all the combination. Yeah, and then we can find all of them, Q3, C3, V3. But this one is for capacitor. It's not related to this one lah. Yeah, this is resistor. Yeah, this is for capacitor. But the working is the same. The working is the same. The working for capacitor also the same. We always find the total capacitance first, and then also find the working also the same. For capacitor also, we start with the total capacitance first, then we go to find the total charge and total voltage, and then finally only we find the each individual charge and each individual voltage. The same thing like resistor now. I just want you to see the pattern. Once you know the pattern, it's easy lah. It's easy. Always find the total capacitance, then we go for total voltage or total charge, then only we find the total, the charge and voltage for each individual capacitor. Charge and voltage for each individual capacitor. And also use the same relationship Q with CV. And also sometimes we have the relationship of voltage, sometimes equal, sometimes voltage have to plus, sometimes 1 over. So all this relationship is almost more, resistor and capacitor is more or less the same, and the strategy is more or less the same. Understand? Okay. Find the resistor total first, then go to the total current, total voltage, then only find individual current and individual voltage. So now we are in the final step already. We are in the final step already. We are in third step already. We are finding individual current, individual voltage. Can you see that? So now I got my I use the V2 here and V3 here. I got the value already. I can find my current 2 and current 3 easily. Yeah. So let's substitute. Why wait? Yeah. Why wait some more? Yeah? So let's substitute the value. So voltage 2 is 8.1776 volt. Current 2 and then resistor 2. What is resistor 2? Resistor 2 is 7 ohm. 7 ohm. Yeah. So put in the 7 ohm and current 2. So let's calculate 8.1776 multiply 7. I got the answer current 2 is, wow, it's quite a big value. Am I right? So I think something's wrong. It should divide, not multiply. Yeah. So 8.1776 divided by 7. Yeah, I should get the current 2 is 1.16. I need to round up to 2 decimal place, because that's the final answer already. 1.17. I should get 1.1. I get 1.17 ampere for I2, and then for I3, this voltage tree is 8.1776, and then I3 R3. What's R3? R3 is 10 ohm. R3 is 10 ohm. Okay, put in the 10 ohm there. 10 ohm, and I3 I get, let's calculate, 8.1776 divided by 10. So I got 0.82 ampere. That's the answer. Am I right? So okay, so is my answer correct? Okay, I write it first. I2 is 1.717. Okay, write it down. I2 is 1.17. Okay, write it over here. And I3 is 0.82 ampere. Am I right? Okay, let's check the answer. Let's check the answer. Okay, so 4 ohm, 9 ohm. 9 ohm. Okay. Wait. 4 ohm and 9 ohm. Oh, 4 ohm and 9 ohm. Okay, this is the current. This is the I1 and or I4 lah. Yeah, this I1. Let me write. This one is I1 and I4. Yeah, and I1 and I4. And then 7 ohm. This one is for I2. This one is for I2. And then this 10 ohm is I3. Yeah, 10 ohm is I3. Okay, is my answer correct? I1 and I4 1.99. 1.9. I1 and I4 1.99. Yes, it's correct. My answer is correct. I1 and I4 is correct. 1.99. And then for I2 is 1.17. I2 is 1.17. I2 1.17. That's correct. Correct again. And then for I3 is 0.82. 0.82. I3 is 0.82. That's correct. So my answer is correct. A big tick over there. It's big tick over there. It's correct for everything I have done. So do you like my channel? Do you like my channel? If you like it, please recommend to your grandson and granddaughter in the future. All right, thank you very much. See you again. Bye.